Okay, you're back for more. Okay, we've got nouns. Those are our objects, our things, our pieces of information, data. One value is a value. Multiple values concatenated together is a vector. Multiple vectors stacked together is a data frame. We know functions. Those are verbs. They take and act on some object. And we have all of these wonderful packages that have lots of functions to apply to our data. So let's get the basics. Now, last time I said here is a great lecture on lots of stuff about Tidyverse. I'm going to hit on just a few little bits and pieces. So try not to overwhelm. Again, I know we're in the deep end, we're doggy paddling, we're just trying to keep our head above water. But here's the basic strokes. We're going to do like the dead man float a little bit here. So, introducing a whole new concept. This is called the pipe. Now, if we have water and plumbing, how do we get water from over here to over there? Well, we could let it run all over the place and hope it gets there, but the best way is to put a pipe. Then the water knows where to flow. Another way to think about it is the pipes connect places or points or going steps. There are links. Our pipes are going to be our links between our steps. Now, we already met the assignment operator. That was the less than symbol with the dash, no spaces, just all mushed together. That assigns information, an object, to a name. We name things and store it as a name with the assignment operator. Today, we're going to learn the pipe, which is another set of symbols that all together, because, we can't just use the letter A, and we can't use the plus symbol. That already has a meaning. So we just jumble some things together to mean connect the steps. So the pipe is this set of jumbled characters. The percentage symbol on that number 5 key, the greater than symbol, that's the period key, and then the percentage sign again. No spaces. All three of those together make a pipe. Now, we already met the function mean, and we can give it a data frames variable. But if there's a missing value, we want to add the argument, separating with a comma, to remove those missing values and ignore them. This is one way with these parentheses to define functions. We do this top box here. We have our verb, and in parentheses we say this is the subject you need to act on, and then after a comma, we'd add some additional complements or arguments that tell it some more information. So I might say kick the ball hard. Kick would be the verb, the ball is the subject, and hard is how you want the kicking of the ball to happen. I might say kick the ball softly, and it changes the way the action happens to the noun, the object. So the same thing here. We can do the mean of a variable. But what if there's missing values? The default is to abort and just spit out another missing value. So we can do the mean of a variable with the option to ignore missing values. So that's the default arrangement, and it works really good. And that's how R has done things for forever. That's been the functional programming of R. But a very brilliant person, who would be my boyfriend if I wasn't married and he wasn't gay, but Hadley Wickham came up with applying a concept that exists in other computer languages to make reading and writing R code a lot easier. So this verb subject complement arrangement works really, really well for the computer. But it's not the way that English and most languages are taught. And the problem happens when you're doing lots of options and lots of steps. It becomes a lot of parentheses nested together or a lot of saving intermediate steps. So the pipe on the surface here is going to look like just a complication, but it has a purpose that makes your life easier. So this first line of code here, when I say, this is the default programming, take the mean of the data frame df's variable age, where I am going to remove the missing values. And it's that verb subject complement arrangement without a pipe. With the pipe, the subject comes first, and then we make a pipe and we have the verb and the complement. Notice the subject is removed from the parentheses and comes first. That's basically all the pipe does, is we have the subject flowing into the verb instead of the subject being inside of the parentheses. Now, it looks like it just caused a complication, but we're doggy paddling, we're waiting for the punchline, it's coming. So here it says take the data frame DF's variable age and then do the mean where I remove missing. It's just a little bit of syntactic arrangement. And for those of you in the ComD that work with language, you might recognize that. So it's just the arrangement of the subject coming first. So our data frame is going to come first, and then we're going to flow the data frame into the action. The reason this comes in to being helpful is when you have multi-step processes. So if I have a robot, I could say, hey robot, bring me the milk from the kitchen. And the robot is going to have to break that down. Even for my, toddlers, I would have to break that down. First, go lift up the cup, then take it to the fridge. After that, you need to pour the milk in and then carry it back to me. So you could break down what you want to have happen in multiple steps. To tell the computer what to do, you have to say the steps separately. So if we were going to do this with the standard programming, I would put the verb and then in the parentheses, the noun and the options or the arguments that go with it. So I would say lift, robot, you're going to do it. So I'm lifting by the robot of the glass on the table. And then I would save that as a new name. So we start off with a robot that's standing there, and then we tell the robot to lift the glass. And now we have a robot holding the glass. Then our second step would be to tell the robot that's now holding the glass to go to the fridge and take out the milk. And we get a new robot. So we are doing one step at a time to build up this robot. We have the robot by himself first, then we have a robot holding the glass. Then we take the robot holding the glass and pick up the milk. And we're going to have to do all 4 steps. What the pipe allows us is to chain or link these different steps into a pipeline. So it's not just that we want to go to A to B because the pipe's not needed there really, but if we want to go from A to B to C to D, maybe we're going to go down the hill, across the gully, and then around the tree and into the house. So the pipeline is what we're trying to get to. So the nice thing here is we can start with the beginning data set and we can flow it into one verb and then into another verb. So we can do repeated actions on the same data frame. So we might want to take our data set and filter out just the control group and then count just the number of people in the control group. Instead of how many people are in the whole data set, how many people, filter to just the control group and then count the number that are there. So we have multiple steps being chained together. We're chaining our verbs. Again, think about that robot. In the traditional language, I would write it. Now, the assignment operator usually points to the thing we're saving it to. So our first changed robot is lifting by the original robot the glass and table. So we have to store our original dark blue robot as a new name. Robot with a prime is what we're showing here. In reality, you just say robot 1 and robot 2. And so we would have all these steps and finally we would get the results. And what happens here is you're storing lots of different pieces of information. So number 1, you have to come up with what you're going to call them, and naming is non-trivial. 2, you got to remember what the names mean and keep them straight. And projects usually don't happen in one setting. They happen over days and weeks and months and even years. And so naming is important. When you write a pipeline, you don't have to name all the beginning steps. So we'd start with our subject and we flow it into each step. So you can see on this slide, we have these flashing pink, hot pink fuchsia colored pipes. So we're going to take our robot and he will lift the glass on the table. And then he will take from the fridge the milk. And then he will pour the milk into the glass. And then he'll put the glass on the table. So each of these steps flows into each other. And this makes it a lot easier to read and write the code. Plus, you're not cluttering your environment, your memory with all these intermediate steps that you have to remember what the difference is between step 1, step 2, step 3. So that's the process. Instead of having to read from left to right, down left, right to left, and back and forth, we can read from the way we're taught English in most languages, from left to right, top to bottom. And the flow of reading and writing makes the code a lot more easy to work with. Okay. So again, we're going to use the pipe to build pipelines. Here's another picture. So we start with the frame of the basic car, then we put on the roof, then we start putting on the paneling, then we apply the final roof, then we apply the windshield, all through the pipeline. We're going to start with our data set and we're going to do steps to it to end up with our finished product. So where are we time-wise? Okay, 11 minutes. We're good. Okay, I'm going to keep going into the homework. Now, anytime you're going to do most projects in R, you're going to have to do some basic steps. And I have them listed here on the slide. You're going to need to read your data in, because it's usually not going to type it in yourself. Usually pre-exists in some kind of format. SPSS, SAS, comma-separated text field, REDCap, Qualtrics, Excel, all these different formats. So you're going to take your data, read it into R. Then you need to assess your data, say, what do I have to work with? Then you might need to clean or wrangle it and change the format, maybe create a new variable from what you have by combining things together or filtering and subsetting. And then you're going to need to analyze your data to get your results. So everyone's always focused on analyzing the data, and that's great. And I'm here to teach you that. However, the first thing you're going to do when you go to do any real life project is you're going to be like, okay, I got to get this data into the computer first. Then I got to see what I have. Then I got to get it ready. The reading your data in, getting it ready, assessing it and getting it ready, those first 3 steps before you can analyze it usually end up taking 80, maybe to even up to 90% of most projects. So this class is not a data wrangling class. It's not a computer software class. But the reality is you have to do those things before you can analyze any data. I have never in my life seen anyone ever given a data set that was ready to go. So we're going to do some of this first stuff today, and it's non-trivial and it takes time, and there's a lot of ways it can go wrong and a lot of different options. So we're just going to do some basics today so that we can be ready to analyze data next week. All right. So we can read in all kinds of data. We already talked about that. So it's usually the same way when you're going to read your data in. The first thing, you have to have your data file. Well, the easiest way is if your data file is living in the same folder on your computer as your RMD notebook file is. If they're in the same folder, it makes life a lot easier. Now, there's times when that can't happen, and I'd be happy to discuss that, but not in this recording. So if it's the case that you have your R Markdown file and your data set in the same folder, it's as easy as this. You're going to give your data set a name so you can use it, because you don't want to just have it declared out into the universe. You want it stored in the global environment brain of R so you can access it. So you give it a name, assignment operator to the name. If it's a comma separated file, it's read.csv, and in parentheses, you quote the name of the file, including the .csv. Now, it's important. Spelling and capitalization and punctuation, huge deal. Now, it's important that your quotes, now this is the quote key by your enter key. You can do single quotes or double quotes, but they have to match. And if they don't, the auto coloring in RStudio will look wonky. So that's a good indication. So comma separator, easiest to read. Tab delimited, not much difference. We still give it a name, assignment operator to the name, read.delimited, and then delim, and then in parentheses, quote the name of the file, including the extension txt. that much harder. Okay, here's the magic. Let's go something harder. Let's go an SPSS file. Oh, read Excel first. You have your data stored in Excel. Now, read at CSV and read DLIM, these two, those functions, those verbs, live in base R. That's where they came with base R. So we're not going to say what package they came from. Other formats, you need a function that's in a specialized package. So read Excel with an X and an L, that package has a function read Excel spelled out. And that's how you would read in an Excel data set. Now, for the first two here, read CSV and read DLIM, they're in base R, they're already there. But for Excel files, you need to use a specialized package. Now, on the first week of class, we went to CRAN and we downloaded to our hard drive the packages that we needed, or at least a good chunk of packages we needed. Those packages are on your hard drive, but they're not active. They're in your library of packages. To activate the package so its pieces, its functions are available to use, you need to call it up with the library command. And this goes back to data used to be read in with cards, like actually punching holes in card pieces of paper and reading them into the computer. My mentor told me about those days. We're not using cards, and we don't have a real physical library, but we use the command library to load or activate the packages we've already installed. Install is downloading it to your computer. Loading with the library command checks it out and makes it available for that session. So in order to use a specialized function from a specialized package, you have to first load the package. So there's Excel, and this works on all the variety of Excel extension files. And then SPSS data sets have an SAV extension, and we use the Haven package to read these in. It's very similar code. We give it a name: Fred, Bob, my data, Jones data, whatever we're going to do. Assignment operator pointing to the name. Then we could say the package name Haven, :, function name. Now, old base R used dots instead of spaces for naming. Newer Tidyverse functions usually use an underscore instead, and that's just an author preference thing. The underscore gives more space. That's why people have started changing to it. As long as you use the right one, you're going to be okay. It doesn't matter which is which. It's just a name. So I did this just yesterday for the first time ever with a Stata data set, and that was a DTA. And all we had to do is say Haven, read _Stata, and then we could quote in the Stata data set that ended with a .dta. Worked the same. So once you kind of get the format down of nouns, verbs, and packages, and knowing what's in the packages you need, the same assignment syntax follows. So let's go to that homework one in the data set on the next recording.